and welcome to the latest OneWeb satellite launch. My name is Georgie Barrett. I'm a tech journalist and broadcaster, and this is OneWeb's 6th launch, sending an additional 36 satellites into low Earth orbit. Yes, today OneWeb are increasing their network to 182 satellites, which will be circling just 1,200 kilometres above us. Now, for those like me who are joining this exciting project for the first time, let's have a quick recap of what this is all about. Today is another step in the OneWeb mission to enable a better connected world. Their revolutionary compact satellites are the size and weight of a fridge, but they're designed to deliver broadband internet anywhere on the planet. By the end of this year, the OneWeb infrastructure will deliver continuous connectivity at latitudes higher than 50 degrees north, introducing a commercial service in the UK, Northern Europe, Canada and Alaska. Once the OneWeb constellation of 648 satellites is complete, wherever you may live or travel, OneWeb will be able to connect you with fast internet and low latency. So whether you're mid-ocean, mid-air or just in the middle of nowhere, the satellites will provide truly worldwide coverage. This will bring vital and much needed opportunity, communication and access to the millions around the world for whom that has been out of reach. In the past year, we've all seen just how important technology is in keeping us all connected. But almost half the world, more than 4 billion people, are not yet online, and for many that are, the service can be slow and patchy. OneWeb can deliver opportunities many of us take for granted, such as remote companies able to do business online, travellers able to access high-speed internet in the skies, schools able to teach without the need for books, connecting classrooms around the world, telemedicine services where doctors or hospitals are available to patients in remote locations, firefighters, police officers, first responders communicating with people in times of crisis or natural disasters. This is OneWeb's mission, connecting the unconnected. And over the next half hour, you're going to see that happening live as their latest satellite group takes flight live from the Vostochny Cosmodrome aboard the Arianespace Soyuz rocket ST31. And being in Russia for this moment is also pretty special because if you know your space history, you'll know this launch takes place just a few days after a significant date. On the 12th of April, Russia celebrated the 60th anniversary of the Soviet Air Force pilot Yuri Gagarin becoming the first human in space. Back in the early 1960s, this was a landmark achievement in a space race that was at full speed. But it would be another 8 years before a man set foot on the moon. And OneWeb are continuing with this trend to pioneer. Their service is designed using a revolutionary network of satellites working together in low Earth orbit, which are connected to user terminals on the ground that work together to transform the connectivity of communities, giving everyone the internet speed they need. Now, none of this would be possible without the support and expertise of Arianespace. They'll be monitoring this launch at every step. So let's now go live to their flight desk in France to join Stefan Israel for an update on the preparations.
Good evening or good morning, everybody. So we are now a few minutes from our Soyuz launch for OneWeb. Soyuz will lift off at midnight and 14 minutes from Paris time. Here we are in our every remote control center, our headquarters close to Paris. We are with our Arianespace and Starsem team. We have some teams in Vostochny for sure. I would like to thank all the teams who have participated in the preparation of this campaign. We have the team from our customer, OneWeb, the team from OneWeb Satellite, the team from Arianespace and Starsem. And now we are really in the last minutes before the liftoff. Everything is going smoothly, so we are now waiting for this liftoff. It will be the 6th mission for OneWeb. We have more than 100 satellites already into orbit, and we have tonight 36 more satellites which are going to be delivered by our Soyuz. So go Soyuz, go OneWeb, and see you later after the mission. Thank you.
Thank you very much for that overview, Stefan, and we'll be returning to the flight desk very shortly. Now, it's easy to talk about connecting the world, but how exactly does it work? Well, OneWeb have a new state-of-the-art service demonstration experience where the team can show you the speed and performance of the network. It's located with Satellite Catapult, an organisation also devoted to finding new ways to use satellite technology. Let's take a little look.
OneWeb is a fantastic new company. In the summer of last year, the UK government decided to invest into the establishment of the company, and what they're looking at doing now is introduce a new type of satellite communications infrastructure. We're going to be able to connect people around the world at fibre-like speeds in ways that we've never been able to do before. Things like autonomous vehicles, drones, robotic shipping, all of these new technologies that we know are coming are going to require the services of OneWeb.
Now we're going to give you a speed test across our network from Westcott to the internet, running live across our satellite network. 95, 100, 120, 133, 145. This is real time, 165.1 megabits per second download speed. What a fantastic result.
OneWeb represents a real step change in what is becoming possible from space. If you can put high bandwidth communications reliably into the back of an ambulance, what does that mean for the sort of services that paramedics might be able to deliver in the ambulance connected to a surgeon connected thousands of miles away? What can you do then? Or on an oil rig?
You're at school in Alaska and you're trying to do online learning. You don't have the connectivity at the moment. With the OneWeb system, you will.
In years to come, I think we will see this point as being as transformational as the rollout of the mobile phones and as the rollout of smartphones in lifting us forward in our ability to connect around the planet. I think OneWeb is genuinely that transformational.
And if you enjoyed that behind the scenes look, then you can see plenty more content like that on OneWeb's YouTube page. Do make sure you go and check it out. Okay, it's nearly time for liftoff. For OneWeb, the countdown to today's launch began many months ago for their team. So let's go live now to OneWeb's Senior Director for Space Infrastructure, Maurizio Vanotti, to talk you through the final stages. It's the moment you've been waiting for, the launch itself.
Thank you, Georgie. It's great to be back for another launch, and it's almost time for liftoff. So let's also welcome back Vincent Boudel, the Advanced Studies Director at Arianespace, who's going to talk us through the final moments in the preparation for the launch. Hello, Vincent. Great to see you again. Over to you.
Hi, Maurizio, and hello, everybody. So I'm very happy to be with you tonight for this new OneWeb mission with Soyuz. So far, final ops in Vostochny are running as expected, and the Soyuz is ready for launch. The first combined operations have consisted in the integration of the complete stack of 36 OneWeb satellites on the frigate upper stage, and followed by the encapsulation phase with the fairing installation. This upper composite has then been transferred to the launcher integration building, where it has been integrated and finally prepared on top of the Soyuz 3 stage. 3 days before the launch, the complete launch vehicle has been transferred to the launch pad, and once arrived on the launch pad, the launch vehicle has been vertically tilted, and the mobile gantry has been safely installed around the launcher. So the launch pad operation have then been initiated with line connections, setup, and several verifications. And the countdown and the dress rehearsal have finally been run successfully at D-2, that is to say 2 days before the launch.
Thank you. Wonderful to see the rocket in position. Vincent, what's happening in the countdown? How are things looking right now?
So far, all ops are running as expected. So the beginning of the launcher final automatic sequence has been initially manually 5 minutes before liftoff, with a turn of cane start position. So an operation called Kluch Nat Start in Russian. Purging operation are as well ongoing, and on Frigate, the transfer has been done to the onboard power supply. So 2 minutes and 25 seconds before liftoff, so a few seconds ago, the umbilical connector was separated. So before this disconnection, the communication between the ground and the launcher upper part were provided by these electrical links. And in the meantime, there is the pressurization of the Soyuz 3-stage tanks. And at S0 minus 45 seconds, the transfer will be done to the 3-stage onboard power.
Less than 2 minutes to go. We've got a long journey ahead. We have a lot of satellites to drop off at different locations. It's a complex mission for Soyuz, and it will be just under 4 hours. Vincent, can you talk us through what is going to happen in the final seconds before liftoff and the ignition sequence?
Yes, concerning the ignition sequence, we will have a progressive increasing of the thrust level. So this progressive sequence enables to check that the engines work nominally. So first there will be the ignition 16 seconds before liftoff, then a preliminary thrust level, so 20% approximately, 11 seconds before liftoff. Then the intermediate thrust level, 85%, so 4 seconds before liftoff. And finally, the full thrust level at liftoff time.
That's great. We are half a minute about from liftoff. I've seen many launches, but at least for me, it's always like the first time. Cannot get used to it. What's your feeling right now, Vincent?
Yeah, so it's an emotional moment as for previous launches. So everything is now ready for launch, and there will be the ignition in few seconds right now.
So the satellites are warm and cozy inside the fairing, and we are ready to go. You can see that we're just a few seconds from launch. Let's follow these together. And we have liftoff of Soyuz ST31 mission. It's very exciting. There's always a bit of tension in these moments. And we are launching in plane 5 today of our 12-plane constellation. There's still a long way to go. 4 hours journey before all the 36 satellites will be released. Right now, the boosters are doing all the heavy work, and they're pushing us against Earth's gravity, and they will burn their propellant in just under 2 minutes. Vincent, can you briefly explain how you're getting telemetry from the rocket?
Yes, Maurizio, indeed, we are getting information from the teams in the CVI. So in French, CVI means control visuel immédiat. So this operational team is tracking the launcher and receives the telemetry data from the launcher. So the team can consequently confirm when major events during the flight have occurred.
The booster separation will occur in just less than 2 minutes. We're looking forward to receiving confirmation of the jetson of the boosters shortly. That will happen after they've burned all their propellant. So we'll not need them anymore, and this is all part of the plan of shedding weight that is not needed. Vincent, when do we have the maximum acceleration levels throughout the ascent phase?
Yes, so we have the maximum acceleration level at the end of the booster phase, so that is to say at the end of the first stage flight phase. So The first stage of the launcher consists in 4 boosters arranged around the central core, so 45 tons each, and each powered by an RD-107A engine, so producing a total thrust of 340 tons at liftoff. So their job is to get the launcher away from the Earth. So we have the confirmation, yes, of the correct separation of the booster. Yeah.
Thank you, Vincent, and we've also seen it live from the camera on board of the Soyuz. So our 36 satellites are sitting at the top of the Soyuz launcher inside the fairing that is protecting them in these initial phases of the ascent. Vincent, tell us more about the purpose of the fairing and confirm separation when you're able to.
Yeah, a few words about the fairing that has several jobs. So most notably, it's protecting the satellites, of course, from the severe conditions of the launch and the atmosphere. So there is the acoustic vibration at liftoff and also friction when the launcher is flying through the dense part of the atmosphere, so at a very high speed. So at the present altitude, there is no more atmosphere, so then no need to maintain the fairing on the launcher to protect the satellite. So the launcher is then liberated from any dead weight.
And when the fairing is jettisoned, this is also the first time that we see our satellites. The satellites are attached to a central dispenser in a configuration that resembles a corn kernel. The satellites themselves look like a truncated pyramid. That's the configuration that maximizes the number of satellites inside the fairing itself. You are able to spot 2 dishes. Those are the gateway antennas that communicate with the ground stations, while what looks like a fanned-out deck of cards is the user link antenna, that part of the satellite that communicates with the user terminal. Now, Vincent is going to take us through an animation that explains the different phases of this launch.
Well, the tonight's mission of the Soyuz started with the 4 booster phase, so during 2 minutes. After the separation, the second stage of the launcher, so the core stage, took the reins during less than 3 minutes, and the fairing is then jettisoned. So after that, few seconds before separation of the core stage, the third stage is ignited, and the central core is then separated. 9 minutes and 22 seconds after liftoff, the third stage will be separated from the nose module. The nose module consists in the frigate upper stage, the dispenser, and the 36 OneWeb satellites. The frigate upper stage mission will start with a first ignition of its main engine to reach the intermediate transfer orbit, followed by a long ballistic phase. And the second ignition will be performed for circularization and injection into the satellite separation orbit. So the satellite release sequence will start with first the separation of the 4 satellites integrated on the top conical part of the dispenser, and then a successive separation of the 36 satellites integrated on the cylindrical part of the dispenser from the top row to the bottom row. 4 satellites at once. So as illustrated on the 3D animation, it means that 9 separation events are necessary for the complete release of the 36 satellites. And between each separation event, the sequence is identical, so 19 minutes, which consist in a series of maneuvers. So first, a tilting of the nose module, then a boost of the frigate attitude control system with a very small delta V during few seconds to ensure enough distance between the satellites and avoid any collision. Then a new tilting of the nose module to the required orientation for the satellite separation. And the separation is ordered by the frigate upper stage, so it is a smooth separation ensured by relaxation of specific springs. So the end of this complex release sequence occurred a little bit less than 4 hours after the liftoff, with the 9th and the last satellite separation.
Thank you. That really helps everyone that is following us from home to understand the journey that awaits our satellites very soon. We are now at the end of the second stage phase. Vincent, can you tell us what's going on now?
Yes, so the second stage is now separated, and it is the turn now of the third stage to burn. The third stage is powered by an RD-120-24 engine, producing a thrust of 30 tons. It burns for approximately 4 minutes and 30 seconds.
That's great. Now let's hear from Georgie again, who has been speaking with one of our partners, the AST group. Georgie, over to you.
I'm joined now by Gregory Darling, who is chairman and founder of the AST group, and he's here to speak more about AST's partnership with OneWeb. Gregory, a very warm welcome to you.
Thanks very much.
So can you please tell us about the AST group? What do you guys do?
What do we do? Well, when the company started, we needed a name and we called it Applied Satellite Technology. So we apply satellite technology to the problems that we come across in the world. So if you haven't got a GSM coverage or a landline, then you need satellite phone or you need satellite connectivity. And nowadays it's internet connectivity. So we sell equipment to a wide variety of users, and then we provide the connectivity and the service and the support and enable people in remote locations to communicate. It's as simple as that.
So you mentioned that you have a wide customer base there. You know, what are the top needs and priorities of them right now?
Well, more connectivity is really what people want because we're used to that. But a journalist has a different need to, say, a ship owner operator, or perhaps somebody who's just going camping. They just want to keep in contact with their mum. But that's not our business. Our business is really much more sophisticated than that. If you're a mine site operator or if you've got a fleet of ships, you need that communication.
Yeah, it's absolutely vital. So, I mean, connectivity is an obvious advantage, but are there other advantages this technology gives your customers?
With OneWeb, for example, it will enable more efficiency to come from operations because you can have preventive maintenance, you can have the real need of people to talk to people rather than just being separated. And very often it's difficult to get people to work in remote locations, and we all expect to have connectivity, so this is a real boost.
Absolutely. It's turned into something that has just become the absolute norm, and you really, really feel the disadvantage if you don't have that connectivity. Gregory, thank you so much for joining us today and explaining a little bit more about the AST group.
The launch phases are always extremely exciting, and we are looking forward to confirming stage 3 separation. While waiting for that, let's take a moment to highlight that we're also deploying our ground network infrastructure, the key elements of which are the satellite access portals distributed across the globe that will enable commercial service introduction and continuous connectivity at latitudes higher than 50 degrees north by the end of 2021. Now we're coming closer to frigate ignition. Vincent, can you update us on the progress?
Well, the third stage is now separated, so and the frigate upper stage is now getting ready to switch on its main engine. So the first step is called the pre-burn phase for a duration of 55 seconds. So it's giving a quick burst of acceleration to push the fluids back in the tank. So this is the first step of the frigate mission. And this first ignition enables to inject the nose module into an intermediate transfer orbit, so an elliptical orbit, and the duration of this boost is just over 5 minutes. So we will be able to confirm, yes, we can confirm now that the successful ignition of the frigate upper stage.
That's fantastic news. Thank you very much. Well, the next phase of the journey is about to start. The frigate is really the smartest part of the rocket with its own brain, and it will execute a series of separations. This is similar to a school bus drop-off, as it will release 4 satellites per stop. And note that as our celestial bus has only one gear, and as after each drop-off it becomes lighter, the frigate will have to fire its engine for a shorter period of time after each separation. Once the satellites are released, the onboard computer wakes them up, and the team at the Satellite Operations Center takes control of the newborn babies. As we are in the process of deploying another pillar of OneWeb's network, we have also launched our first OneWeb Innovation Challenge, aiming at identifying new ideas to promote and nurture innovation in space. We are inviting industrial and engineering partners, academia, and research professionals across any sector to present proposals to innovate a new generation of satellites. So do check out our website for more information about the OneWeb Innovation Challenge 2021. I'd like to thank Vincent for being with us today and taking us through the key phases of OneWeb Launch 6. Thank you to all of the colleagues at OneWeb for making this possible. And thanks to those of you watching from home. We've enjoyed witnessing together another exciting moment of OneWeb history. And now I'm going to hand back to Georgie.
So, there you have it. Another batch of OneWeb satellites are on their way to take their place in low Earth orbit. Wasn't that an incredible thing to watch? And it won't be long until more satellites will join them. Throughout 2021, OneWeb will continue to build their network as there are only 2 launches to go before there are enough satellites to connect some of the most remote places in the Northern Hemisphere. Thanks to the team at OneWeb and to Arianespace for allowing us to join them live and for all their insights. It's been brilliant to see OneWeb's mission in action as they transform the way we think about connectivity. A little bit of history in the making. You can follow the project and this mission's progress across the OneWeb social media channels. Don't forget to also look out for the next launch coming soon. From me and all the team at OneWeb, thank you for watching and goodbye.